The next theorem, which is a higher generalization of Rolle's theorem, is the Lagrange's mean value theorem, or sometimes simply called mean value theorem. Since Lagrange was the first person to have published this theorem, he is given credit and the theorem is named after him, and it's called Lagrange's mean value theorem. If y is equal to fx be a given function such that fx is continuous on the closed interval a to b and fx is differentiable on the open interval a to b, then there exists some point c somewhere between a and b such that f prime c is equal to f of b minus f of a by b minus a. So what does this mean when we look at it graphically? So this black colored is the graph of some function y is equal to fx, and you have the initial point a and the final point b. Somewhere in between, if you draw a pink colored tangent, then the slope of that tangent is equal to f prime c. What Lagrange's mean value theorem says is that it is exactly equal to the slope at the end points a and b. F of b minus f of a divided by b minus a gives us the slope of the secant line between a and b. That is, when you draw a line connecting a and b, the slope of that line will be exactly equal to the slope of tangent drawn at some point c. There exists exactly one point which satisfies this condition, and that point lies somewhere between the starting point and end point of the function. So that is what Lagrange's mean value theorem says. So what are the consequences of these mean value theorems? The first consequence is that the zero derivative implies a constant function, because if fx is differentiable and f dash x is equal to 0 at all points on an interval, then f is a constant function on I, because that would give us f of a is equal to f of b, which means that the value of the function between any 2 points is not changing at all, which can happen only when the function is a horizontal straight line. A horizontal straight line means a constant function. The second consequence, functions with equal derivatives differ by a constant, right? If two functions have the property that f prime x is equal to g prime x, then for all x of an interval I, fx minus gx is equal to c on this interval I. And this also leads to the third consequence, which we have already studied, intervals of increase and decrease. So suppose f is continuous on an interval I and differentiable at all interior points of I, and if f prime x is greater than 0 at all interior points of I, then f is decreasing on I.